Hi, this is a recorded lecture for the IB DP Design Technology, topic 4.2D, plastics. So plastic is a very useful material and also problematic, which we'll talk about as we go through this topic. This is a really interesting video. This shows kind of the idea of how plastic came to be what it is today. And it's pretty interesting. So please have a look at that. The big ideas here are that most plastics are produced from petrochemicals, but because of environmental concerns, bioplastics are being developed as well as new methods of reuse, reduce, and recycle petroplastics. The raw materials for plastic is crude oil, and it's extracted from one country, then exported to other countries where conversion takes place. Then the plastic is re-exported at considerable cost due to extraction, transport, and conversion. When selecting materials, designers must consider the moral, ethical, and environmental implications of their decisions. Here's a couple articles about plastic. Have a look at those. So first of all, plastics are polymers, and polymers are very large and usually long molecules composed of base units called monomers. So the word mono means one, and in this case, mer kind of means molecule. So a monomer is one molecule. And when you link them together so that you have many linked molecules, or poly, so poly means many, so polymers are many linked molecules. And that's the idea with plastic. We're linking together many, usually very long, molecules. Plastics are formed from hydrocarbons. So hydrocarbons are going to have hydrogen and carbon, such as ethylene. So you can see that ethylene has 2 carbons and 4 hydrogens, or propylene, which has 3 carbons and 6 hydrogens. Ethylene and propylene are obtained from crude oil, and you can see a flow chart of how this works, right? When we do our fractional distillation of crude oil, you're going to get diesel oil and heating oils. That's about 70%. You get light petroleum spirits or benzene, and then you have some other uses. You have the raw materials for chemicals, which are plastic manufacturing. You got your polystyrenes, you've got your polypropylenes, polyethylenes, polyester, nylon, and PVC. So this is kind of a flow chart of how we use crude oil. The first type of plastic you really need to know, and they sort of fall into 2 big groups. So the first big group of plastics that you need to know are thermoplastics. Now you have to be a little bit careful because the second group are thermosetting plastics. So the vocabulary term is very similar to each other. So you really need to be able to tell the difference between the 2 of them. So thermoplastic is a type of plastic that can be heated and formed into a new shape repeatedly. This is the key thing. And we'll see this with thermosetting plastics. You can't do that. So thermoplastics are linear chain molecules with weak secondary bonds between the chains. I'll show you a picture of what that looks like in a minute. Their general characteristics are they're ductile. So you have to remember what ductile means. It means it can be drawn into a wire. They have low stiffness. So if you think of like a shampoo bottle, which is high density polyethylene, that's HDPE. They're easily injected into a mold, they can be reshaped after heating, and they're easy and cost-effective to manufacture. So here's some thermoplastics, an example of what I mean by that. So remember, they can be reformed into new shapes because there are no links between these chains. So you can see that there's kind of a space between this, and you'll see with thermosetting plastics, there's an actual link between these monomers right here. So that means that you can melt them and reshape them. So that's the key thing about a thermoplastic compared to a thermosetting plastic, is that you can reheat it, reshape it into a different form. And that makes them easy to recycle. So here's some types that we have. We have polypropylene, and those are the lowest density thermoplastics. They have good toughness. Remember what toughness means, that they don't propagate cracks. They're resistant to fats. They have a high resistance to temperature. They have good fatigue resistance. They're semi-rigid, translucent, and recyclable. And if you think of like buckets and bowls and crates, toys, food containers, juice bottles, straws, coat hangers, furniture, so lots of things are made out of polypropylene. We have polyethylene. This has a low stiffness. So remember that stiffness is the ability to resist deformation. So they're going to have low stiffness. They have high toughness. They don't propagate cracks easily. They're translucent. That means light can pass through them, but you're not going to get a clear image. And they're commonly like high density polyethylene or low density polyethylene. They're definitely recyclable. So water bottles, food storage containers, plastic tubing, light work surface, shampoo bottles, flower pots, those are all made out of polyethylene. We have polyethylene terephthalate. This is a hard word to say, but it's terephthalate. It's high strength, it's rigid, it's thermal resistant, and it's recyclable. And this is things like soda bottles and water bottles. If you think of those clamshell food containers, the ones that are like clear plastic that open and shut, we have fibers such as polyesters or parts made in injected molded. ABS is something that we use quite a bit. It's high impact resistance, it's got high toughness, it's got dimensional stability, good stiffness, good workability properties, and it's a versatile material. So you can think of phone handsets, rigid luggage, domestic appliances, handles, some helmets. And the one that you're probably most familiar with is Lego. So Lego is made with ABS. HIPS, or high impact polystyrene. It's easy fabrication, high impact strength, good aesthetics. It comes in various colors. It's rigid and stiff. It's low cost, dimensionally stable, good workability, and not biodegradable. So toys and kitchen utensils, shelves, signs, product casings, things like that are made out of high impact polystyrene. PVC is polyvinyl chloride. It can be stiff or flexible when a plasticizer is added. It has good aesthetics, lots of different colors, low cast. It's not biodegradable. So one of the main uses of PVC is with piping. So for instance, a lot of plumbing in houses is PVC pipes. But also water bottles, cling film, credit cards, toys, shampoo bottles, imitation leather, all of these things are made out of PVC. Let's talk about thermosetting plastics. So this is a type of plastic that form into a shape, cannot be reformed into a different shape. Thermosetting plastics are linear chain molecules with strong primary bonds between the chains. They have high stiffness, high strength as compared to thermoplastics, and cannot be reheated and remolded. It will usually char or burn. So you can see in this picture right here, when I talk about these bonds between the monomers, you can see that these red links right here. And this makes them really stiff, but it also makes it so that they can't be reformed when you heat them. They essentially just degrade and burn and break apart in ways that we don't want them to break apart. Some different types of thermosetting plastics that we know about are polyurethane. So this is a hard, like fiberglass, or it can be soft or spongy also. It has a wide range of hardnesses. It has good tensile and compressive strength. Toughness is good, good electrical resistivity, good bonding properties, and good resistance to damp environments. So things like wheels and wing parts, sponges, finishes, and toys are made with polyurethane. Urea formaldehyde has a high surface hardness, high tensile strength. It's electrically resistive. It has low resistance to damp environments. And you can think of contexts like manufacture of man-made lumber, so MDF or particle board, adhesives, insulation, wrinkle and shrink resistant textiles. All of these are made with urea formaldehyde. Melamine resin has a high hardness. It's one of the highest of plastics. It's highly chemically resistant. It is mediumly fire and heat resistance, and it will decompose under great heat. It's resistant to moisture. So kitchenware, like plates and utensils, are one example of where you see melamine resin. Decorative laminates on countertops and tabletops, or fire retardant clothing is another place you'll see melamine resin. Epoxy resin has a high thermal resistance, high chemical resistance, and high toughness. You often find this in adhesives, fiber optics, electrical insulators, and transformers. Craft and jewelry industry also use epoxy resin. So when we want to recover and dispose of plastics, nearly all plastics can be recycled depending on economic, technical, and logistical factors. So you have to pay attention to those things when you're recycling. So thermoplastics can be easily recycled, but there's a range of chemical compounds and therefore they need to be sorted for recycling. Thermoset plastics are not easy to recycle and they're expensive to do so because you need to grind them into a powder, which takes time and has a lot of costs. So they're often just sent to landfills. Some plastics are not accepted at recycling plants due to its chemical compounds and the facility's capabilities. This is a recovery and disposal chart. So you can see that these things will tell you what the common products are and how they are recycled. All right, thank you for watching.